So in the last class, we have seen 8 different elements, okay, for the geometric design of taxiway. So why is it necessary that you need to geometrically design the taxiway? Whenever we have seen that the speed of the aircraft on the runway and taxiway is different, right? The speed on the taxiway is very less when compared to that of the runway, and hence the design specifications recommended by ICAO is also different. Hence, we need to look into this geometric design of taxiway separately. Though the factors which is going to finally decide the geometric design of runway and taxiway remains the same, the values or the standard specifications will be vary. Okay, and we have seen 8 different elements, and the 8 elements which will finally design the geometric design standards of your taxiway are: length of taxiway, longitudinal gradient of taxiway, rate of change of longitudinal gradient, side distance, transverse gradient, turning radius, width of safety area, and finally width of taxiway. So these are the various elements that you are going to look into for geometric design of taxiway. So starting with the length of taxiway. So what is exactly the length of taxiway? The distance between the apron, okay, the apron portion where you are holding your or accommodating your aircraft for refueling purposes, for loading and unloading of passengers, goods, etc. Okay, so the distance between this apron and the entry point or exit point of the runway is known as, is considered to be the length of the taxiway. So suppose you have your terminal building over here. Maybe this is your apron area and this is your runway. So you may be having one taxiway from this apron that connects your runway in the midpoint. The other thing you may have here, okay, and also you can have a taxiway that connects the other end of your runway. Okay, so maybe the wind is flowing in this direction. So whenever your flight is taking off, it can make use of this way, this as the entry point. So this is the entry point of your runway and this will be the exit point. Okay, so the distance between the apron and the entry point or apron and the exit point. Okay, similarly when it comes to this taxiway, distance between the apron and this point is the length of your taxiway. And as such, there is no limit. Okay, no limit is recommended or specified by ICAO for the length of taxiway. You can provide any length for your taxiway, but it is always advised to choose the shortest path. Okay, shortest path or shortest route in order to connect your apron with the runway. And why it is always recommended to go for the shortest path? To save fuel consumption. Okay, so fuel will be consumed less if you are preferring a shortest route, or else if you are thinking of a route something like that, it is going to use more fuel, so you won't be able to save much on your fuel. Okay, so always prefer the shortest route wherever it is practically possible. Hmm? And as such, there is no limit specified by ICAO. So that is the length of taxiway. And second factor is the longitudinal gradient. Okay, so coming to longitudinal gradient, so this is longitudinal gradient. Okay, assume that, so this is your runway. Okay, this is the center line. If you take this longitudinal section, if the gradient is steep, okay, if you have got a steep gradient throughout your runway length, then again it will lead to more fuel consumption. Like you upgradient, in order to climb this upgradient, your aircraft needs more fuel. Okay, and hence ICAO has recommended maximum value. Okay, maximum value of longitudinal gradient depending upon the type of the airports. For A and B type airports, it is always recommended to have a maximum value of 1.5%, and for C, D and E type, the maximum value of longitudinal gradient recommended by ICAO is 3%. This is the maximum values, okay? Maximum values for your longitudinal gradient. Now let's go to the third element, third design element for the taxiway, that is rate of change of longitudinal gradient. So depending upon the rate of change of longitudinal gradient, it will finally affect the side distance. Okay, side distance. Because if you are providing sudden ups and downs or sudden changes in your longitudinal gradient, then unlike highway, you need more distance ahead, right? At least 50% of your total runway length should be there for your side distance in order to see an object which is almost 300, about 300 meters to 1.5 meters, right? So in order to help the availability of side distance within this taxiway, okay, again we have got standards recommended by ICAO depending upon the type of airports. For ABC type of airports, the maximum rate of change of slope, the value is 1%. D and E, for D and E type airports, the value is 1.2%. Okay, and the maximum rate of change of slope for 30-meter length, of the vertical curve is considered. So along the runway you are along the taxiway you are taking 30-meter lengths. Okay, 30-meter taxiway stretch, and within that stretch, for ABC type of airports, you are permitting only 1% rate of change of slope. Okay, so when you consider every 30-meter stretch for ABC type of airports, the maximum limit or the maximum rate of change of slope that you can provide is 1%. Similarly, when it comes to D and E type, when you consider 30-meter stretch on your taxiway, the rate of change of slope should not exceed 1.2%. Okay. So, similar to highways, in runways and taxiways also, whenever the uh, stretch that you are considering is different, okay, the rate of change of slope also differs, and also the longitudinal gradient will be also different at different stretches. Okay, it is not throughout the same. For a particular runway, the longitudinal gradient is not the same. Similarly, as the longitudinal gradient is differing at different sessions, you have got a different values of rate of change of slope. And always it is insisted that you should provide this rate of change of slope in a gradual manner, okay, in order to avoid discomfort to the passengers, and also to provide feasible side distance. Then the fourth factor is side distance. So in the case of taxiways, you know that the speed is very lesser when compared to runways, right? And hence we need a smaller side distance when compared to runways. And here for A and B type airports, okay, the surface of the taxiway should be seen, the surface of the taxiway should be seen for a distance of 195 meters from a point of 2.10 meter above the taxiway. Okay. So the one who is about 2.10 meter above the taxiway should be able to see the surface of the taxiway, which is 195 meters ahead of him. So here somebody is observing, okay, somebody is observing, and the height of the one who is observing the taxiway is 2.10 meter, and he should be able to see the surface of the taxiway at least 195 meters ahead. Okay, so this is the side distance requirement for taxiway. 195 meters side distance should be the for the person who is observing the taxiway at a height of 2.10 meters for the taxi above the taxiway. Okay, and coming to C, D, and E, these distances are different. The surface of the taxiway should be seen for a distance of 300 meters from the point, okay, from a point which is above 3 meters. For A and B type of taxiways, airports, in such airports, the side distance requirement of a taxiway is in such a way that the surface of the taxiway should be seen for a distance of 195 meters from a point 2.10 meter above the taxiway. And for C, D, and E type of airports, the side distance requirement of a taxiway is in such a way that the surface of the taxiway should be seen for a distance of 300 meters from a point 3 meter above the taxiway. So these are the specifications for the taxiway regarding side distance. Okay. So just now we have seen the length of the taxiway, longitudinal gradient of the taxiway, rate of change of longitudinal gradient, and side distance. Now let's move to the fifth point. That is transverse gradient. So why we are providing transverse gradient? Transverse gradient or lateral gradient. So this is a runway. So if you cut the section perpendicular to the center line or alignment of your runway, then you'll be considering the transverse gradient, right? Similarly, in the case of taxiway also, you need to provide a transverse gradient. And the purpose of the transverse gradient remains the same for highway, railway, then runway, taxiway. Okay. What is the purpose? For the quick disposal of surface water. Okay. So otherwise, there are chances that soon after a rain, there will be enough water on the surface of your runway or taxiway, which is not at all desirable. Okay. Again, depending upon the type of airports, the maximum transverse gradient that can be provided for ABC type of airports is 1.5%, and that of D and E type, the maximum gradient that can be provided is 2%. Okay. And also ICAO has not mentioned about the minimum value that should be provided. But always it is advised to provide at least 0.5%. Okay. Though the minimum value is not recommended by ICAO, it is always advised to provide 0.5% so that the quick disposal of surface water takes place and it won't cause any hindrance to the movement of the aircraft. Okay. And the sixth geometric element is turning radius. Turning radius. And when we discussed about the aircraft characteristics, we have seen that minimum turning radius and minimum circling radius, right? Hope you remember that. So whenever there is a change in the direction of taxiway, so in different sketches, you have seen that the taxiway is a path which connects your apron with your runways, right? So suppose the aircraft is accommodated over here on your apron, and if it needs to reach the runway to take off, then it need to take a turn over here. Again here it need to take a turn, and finally again here it has to take a turn in order to reach the runway, right? So without reaching anyway, suppose some people may think that, yeah, suppose the aircraft is over here, then we can just, it can reach the runway straight ahead with the help of a straight path, but still it need to take a turn over here. So this turning is an essential process which you need to consider also. So because of that, from the sketch itself, it is clear that there is a change in direction is required here, right? So whenever there is a change in direction, you need to know that you need to provide a horizontal curve. Okay, without the help of a horizontal curve, you cannot change the direction. Though you have got a small curve, then also you need to provide a small horizontal curve, you need to consider what is the value of r over here, right? So the turning radius can be determined with the help of capital V square by 125 small f, where V is the radius of the curve in meters, capital V is the speed of the aircraft in kilometer per hour. Since we are talking here about the taxiway, this is the speed of the aircraft on the taxiway, okay? And F is the coefficient of friction between the tire and the pavement surface. And for all the calculations, when coming to airport engineering, coefficient of friction is considered as 0.13. Okay, so this is 0.13. Now, seventh design element is width of safety area. So this width of safety area you have seen in runway also, right? So it is partially paved shoulders on either side plus area which is graded and drained. Okay. So in the case of taxiway also, you'll find some shoulders along the taxiway area on either side of your taxiway. And they will be partially paved, not fully paved as taxiways, okay, because the shoulder area will be utilized at times of emergency only. Mm. But they can be graded off properly, and proper transverse gradient can be provided so that again there is no surface water on the top of the shoulders exist. Okay, and whenever a jet craft is likely to make use of these facilities, it is necessary to protect the shoulders from soil erosion. Okay, so when compared to other aircraft, the jet aircrafts are having higher loading capacity, and the total weight will be also very much high, and it is necessary to protect the shoulders from soil erosion due to the high speed and high load of the jet exhaust. Okay, and in such situations the minimum width of the shoulders, so here the shoulder itself act as the safety area, and the minimum width of the shoulders is 7.5 meters. So on either side of the taxiway you should provide a minimum width of 7.5 meters. Okay. Now next is width of taxiway. So you need to consider what is the width of the taxiway, right? Again, it depends upon the type of the airports. So these are the widths recommended by ICAO for A and B type airports. The width of the taxiway is 22.5. For C type, the width is 15 meters. For D type, the width of taxiway is 9.9 meters, and for E type, it is 7 meters. So these are the width of taxiway depending upon the airport type, which is recommended by CAO. Okay, So when it comes to the width of safety area, you have to provide 7.5 on either side. So the total width or width of the safety area will be 22.5 plus 50 meters for A and B type. Okay.